So the first thing I want to do for this video is make sure that you know there's a correction to be made. This is a plus right there. Okay, so now the instructions say for each of the graphs below, choose one of the equations from the equation bank that you think fits the graph, and then explain in words how you can tell without a graphing calculator what the rule reveals about the graph. Okay, so I need to look at each of these. Now each of these is in a different form. So you need to know what the different forms reveal, right? So you need to remember that standard form looks something like ax squared plus bx plus c, right? A number times x squared plus another number times x plus another number, no parentheses. And standard form reveals y-intercept right here. So if you're looking at things in standard form, just look at that last number and it should tell you the y-intercept, and then you can go scouting to see which ones have the y-intercept that yours does. Factored form. An example of factored form should have like x minus h and x minus k, right? Something times something else. And this reveals your x-intercepts. And then vertex form we just went over, right? So anything that kind of looks like a number times some parentheses squared plus another number on the outside, that reveals your vertex. So I'm not even going to do the vertex forms because you should be able to tell, like vertex form here, here, and here. Identify the vertex and see if it matches up with anything. In standard form, I think we've gone over that enough that you should be able to just look at this last number and tell what the y-intercept is and try to see if that matches. So I'm going to focus on a factored form problem. So a factored form problem, I'm going to take this one right here. So I'm going to say, okay, this reveals, I know this is factored form, so from this I should be able to quickly get to my x-intercepts, or my zeros, where it crosses the x-axis. But in order to do that, there's just a little more work to do. I need to take each factor and set it equal to 0. So I'm going to take negative 2x plus 1 set equal to 0, and I'm going to take x minus 3 set equal to 0. Because the idea is that when I'm crossing the x-axis, my y is always 0. Y is always 0 when I'm crossing my x-axis because I'm not going up or down. So I'm trying to find out where does y equal 0. Well, y is going to equal 0 when either this factor equals 0, because 0 times something is 0, or this factor is equals 0, because 0 times something is 0. So that's the logic behind why you do that. But just the quick and easy way is set it equal to 0 and solve. And this is just basic middle school solving. Divide by negative 2. So x equals positive 1/2, or which is the same thing as 0.5. And then here, add 3 to both sides, x equals 3. So I now know 2 of my x-intercepts, which there are only 2, right? So I need to find a place where a graph, if this matches up with something, it will match up with something where it crosses the x-axis at 0.5 or at 3. So I need to go around and look at the different places. So this is crossing at negative 5 and negative 1, so that's not it. This is crossing at some decimals, so that's not it. Negative 1, positive 3, that's not it. Here, positive 5, positive 3. So I just found one of the parabolas that crosses at positive 5, positive 3, right? So I'm pretty sure that I found my match. This equation with this graph, so I'm going to write the equation y equals negative 2x. I don't have much room, right? You can always do this on a different sheet. I'm going to write it down here. Y equals negative 2x plus 1 and x minus 3, right? And then it needs an explanation why. So factored form, set each factor equal to zeros, and found my x-intercepts. Okay, so that's how I know. This was factored form. I set each factor equal to 0, and I found my x-intercepts. That's how I knew to match this with this. I used the idea of x-intercepts. Now, if I was trying to find this somewhere, I wouldn't use the idea of x-intercepts because that's standard form. So this one would require a different explanation. And notice that there's 8 equations but only 6 graphs, so there's going to be 2 that don't have a match.